Welcome to our OSHA Focal Point series. I'm Dr. John Mulroy, Director of the Pennsylvania OSHA Consultation Program, housed in the world-renowned Safety Sciences Department here at Indiana University of Pennsylvania. These videos were created with the essential, need-to-know OSHA compliance information to supplement your safety and health training. Addressing OSHA's most frequently cited standards, like lockout-tagout, fall protection, hazard communication, and machine guarding, these videos can help your organization anticipate, identify, evaluate, and control workplace safety and health hazards. We hope these critical OSHA focal points assist you in preventing future injuries and illnesses. If you still have questions or you need no-cost OSHA compliance assistance, we're here to help. All you need to do is reach out to us at IUP using the link below and request this no-cost OSHA compliance assistance service. It's that easy. Thank you for choosing the Focal Points video series. Be sure to hit the subscribe button to be the first to know when new safety and health content is added to this channel. Have a safe day, everyone. Today's topic is electrical safety, and the purpose of today's topic is to provide you with the essential need-to-know information about the hazards associated with electricity. So during this short presentation, we will briefly discuss the following topics, which include common electrical hazards, electrical protection methods, and safe work practices. So the key terms, we're talking about electricity, and this is the movement of free electrons between the atoms. And there's three related terms that we need to be concerned about. That's current, resistance, and voltage. We need to understand conductors, and we need to understand insulators and how insulators can protect us. We also need to understand the principles of grounding. Electrical hazards include burns, shock being the most common. There are three types of electrical burns that you can suffer: electrical, arc flash, and thermal contact. With electrical hazards and burns, the body becomes part of the circuit. You may have a reflex response, the passage of electric current through the body. You may actually clutch onto a live circuit and not be able to let go. Electrical hazards include electrocution, which can be fatal, and that is a result of a human coming in contact with a lethal amount of electrical energy. Other electrical hazards include arc flash, which is the sudden release of electrical energy through the air. We are talking about thermal radiation, simply heat, and bright, intense light that can cause thermal burns. You got to remember, in an arc flash situation, temperatures of that exploding and failing equipment can reach 35,000 degrees Fahrenheit. That's nearly 4 times the temperature of the surface of the sun. We also have arc blast. And in an arc blast situation, we're talking about high voltage arcs producing considerable pressure waves that can kill. They also rapidly heat the air around you and can contribute to the thermal burn hazard. Electrical hazards include fires. Most of these result from problems with fixed wiring in a facility. You can have problems with cords, plugs, receptacles, and switches. All this equipment can also lead to an electrical fire. Another electrical hazard that you as a worker need to be concerned about are electrical explosions. And this occurs when electricity ignites an explosive atmosphere in the workplace. Got to remember that electricity is a source of these hazards, and all these hazards are of equal importance. And this lesson focuses on eliminating these potential electrical hazards. Common hazards in the workplace include contact with overhead or buried high voltage lines. And the risk of coming in contact with these lines is electrocution, burns, and falls. Other electrical hazards include crane operations on the job site, handling ladders, moving ladders, or positioning ladders on the work site, and operating aerial lifts near power lines. It is important to remember that we need the utility to cover overhead power lines to ensure that they are protected. And if you come in contact with a power line, death is probable. Shock and burn hazard severity depends on several factors. This includes a pathway through the body, the amount of current traveling through your body, the length of time of that exposure, and whether your skin is wet or dry. When it comes to water, you need to remember, water is a superconductor. It allows current to flow more easily in wet conditions and across wet skin. How much current is needed to suffer an injury? Between 1 and 5 milliamps, you may feel a slight tingle or even a slight shock. It may not be painful, but it can be disturbing. Up to 25 milliamps, you may feel pain and you may lose muscular control. Up to 30 milliamps, you have muscle contractions and you may freeze and not be able to let go of that conductor. Over 50 milliamps, it's extremely painful. You may suffer respiratory arrest, severe muscular contractions, and even potential death. Between 1,000 and 4,000 milliamps, the pumping action of the heart ceases. And over 10,000 milliamps, cardiac arrest, severe burns, and death is probable. Other common electrical hazards include damaged or bare wires. Fault current can travel through a body if that power supply is not properly grounded, the pathway has been broken, and there are live parts or bare wires that are exposed. So extreme conditions and rough treatment when you're handling your equipment on the job site can change electrical equipment from safe to hazardous. Other common electrical hazards include improper use of extension, or as OSHA refers to them as flexible cords. We need to make sure that we protect them, that we use them properly, and they're properly rated for the capacity. Capacity is affected by the size of the wire, so it's important to know that a 14 gauge wire can carry 15 amps, whereas a 12 gauge wire can carry up to 20 amps. This all depends, of course, on the length of the cord. And generally speaking, any cord over 100 feet requires you to size down, going from a 14 gauge to a 12 gauge. Common electrical hazards also include power strips. We can easily overload these power strips because of multiple plug arrangements. Most of this equipment will have overload protection, but often malfunctions will result in a workplace fire. We always want to use fixed wiring when it's possible. Portable heaters and appliances, especially in cold weather situations, can result in electrical fires. We need to make sure that we follow all manufacturer recommendations when we're using this type of equipment, and never use a portable heater with a power strip. Other protection methods that we can use are ground fault circuit interrupters. They're designed to protect people from electrical shock. They can detect ground faults and interrupt that electrical current, and they will limit the duration of electrical shock. There's 3 types of GFCIs. One is a receptacle. The second is a temporary or portable GFCI as part of your assured grounding program. And lastly is a circuit breaker GFCI. Other protection methods include inspecting portable tools and extension cords on the job site. You want to inspect them thoroughly prior to their use for any cuts, abrasions, or damage. You want to ensure that double insulated tools are used. You want to replace any old, damaged, or misused tools, and you want to remove and tag out any damaged tools from your job site. We want to make sure that we use power tools and equipment as it was designed by the manufacturer. Never carry a tool by its cord. We never want to yank on the cord in order to disconnect it. We want to keep all power cords away from heat, oil, and anything that could damage the insulated cords. We always disconnect this equipment when it's not in use, and we want to ensure that we avoid any type of accidental starting. We don't want to hold our fingers on the switch button while we're carrying a plugged-in tool. We will always want to use the proper personal protective equipment. We want to make sure that our tools are stored in a dry place when we're not using them. We never want to use any tools in a wet situation or in a damp environment. And if we must work outside, we want to ensure that we have ground fault circuit interrupters. We want to make sure that our work areas are well lit, and we want to make sure that our power cords never create a trip and fall hazard. How do we protect ourselves most effectively? We want to follow lockout tagout. And lockout tagout is our most essential safety procedure when it comes to protecting ourselves from electrical hazards. Lockout tagout protects our workers from injury when working on or near electrical circuits or any type of energized equipment. And it prevents workers from coming in contact with operating equipment such as blades, gears, shafts, or live current. Electrical protection methods include source identification. On any job site, we want to make sure that our breakers are labeled accordingly for the circuits that they are protecting. We want to make sure that we mark all disconnect means accordingly for all the equipment that they service. And we want to ensure that we identify all voltages with proper labeling. To get more help on electrical safety, go to OSHA.gov. Thank you.